Welcome to Lesson 12, the close. Back in Lesson 1, we watched NGINX climb from 1,047 to 52,103 requests per second, a 41x jump. That number wasn't magic, it was methodology. Today, you learn the discipline behind it. Measure first, tune one thing, measure again, and then we graduate the entire advanced series. Here's the shape of the hour. 4 pieces. Then a closing reflection. First, work, the multi-threaded Lua scriptable benchmark that doesn't tap out before NGINX does, the way AB tends to. Second, the disciplined loop. Baseline, one change, measure, compare, repeat. Third, the metrics that actually matter. RPS is the headline, but P95, P99, and error rate tell you whether you're fast or just lying to yourself. And fourth, graduation, naming everything those 13 lessons put in your hands. Before we dive into WRK, take a moment with the map. 6 phases, 13 lessons, every box checked. You started at L00 with orientation and goals, moved through tuning, perf, proxy, cache, fast CGI cache, into the protocol layer with HTTP2 and HTTP3 and the stream module. Then you extended NGINX itself with Lua, NJS, and dynamic modules, hardened it with MTLS and mod security, and made it observable with Prometheus and Kubernetes Ingress. That's the arc, a single config to cloud-native patterns. Today closes it with benchmark methodology and graduation. First piece, the most honest tool in the box, RK. Threads matched to CPU count, 400 connections, 30 seconds, that's your baseline command. But the average is a lie. Always pass, latency, and read the distribution. 23 milliseconds average looks great until you see 99 at 245 and P99.9 at 890. That's the tail your users actually feel. And run it from a separate machine, co-located load generators steal the CPU you're trying to measure. With WRK in hand, here's the discipline that turns numbers into knowledge. Change one thing, rerun the identical command, and own the result. Watch the loop. Baseline at 12,000, send file and gzip take you to 19, proxy cache doubles you to 38, HTTP2, and worker connections push 52. Then keep a live timeout at 300 seconds, costs you 7%. Revert, and you've still learned something. 4x, own to 5 specific changes. That's the method. And the method only works if you're measuring the right things. Rec-sec is the headline, but it's also the easiest number to lie with. High throughput with a 1% error rate isn't fast, it's broken. P50 tells you what the median user feels. P99 is the angry user tale, the one that wakes you at 3 in the morning. Error rate is non-negotiable, always under 0.1%. 6 numbers, 6 different stories. Read them together, or you're flying blind. So here's the script that enforces all of it. 3 runs, 30 seconds each, from a separate VM so you're not measuring the load generator stealing CPU from NGINX. Label your baseline, make your one change, run it again with a new label, then grep for requests per second and the 99th percentile. The diff between those 2 files is your evidence. Not a feeling, not a hunch, a measurement you can defend in a code review. And that discipline matters because every NGINX tip on the internet is simultaneously right and wrong. Right for the author's 4-core blog, wrong for your 16-core API talking to a 200 millisecond backend. 3 principles hold the whole methodology together. Your workload is unique, so generic advice is a starting point, not an answer. One change at a time, because causality dies the moment you touch 5 directives at once. And measurement is the lock on the loop. Without before and after numbers, every tune is faith-based. Numbers ship, opinions don't. So here's the cheat sheet. Print it, pin it, whatever works. The default work invocation gives you requests per second and average latency, but always add the latency flag for the percentiles that actually matter. P95, P99, P99.9. Right-size threads and connections to your VM. 12 and 400 is a starting point, not gospel. Fall back to Abe only when WRK isn't available. And the 2 steps at the bottom are the whole methodology in one breath. Baseline before any change, then move 1 variable and remeasure. Now you put it all together with 3 drills. First, 30 minutes establishing a trustworthy baseline. Run bench 3 times on a separate VM and confirm your variance stays under 5% because an unreliable rig poisons everything downstream. Then 60 minutes applying proxy cache from lesson 2 against a real endpoint, expecting a 5 to 50 times jump in RecSec and P99, collapsing to single-digit milliseconds. Finally, 30 minutes tuning one more thing of your choice. And whether it helps, hurts, or does nothing, you've run a real experiment with evidence instead of opinion. With the drills behind you, the question becomes where to point your attention next quarter, and there are 5 honest directions. NGINX Plus, if your traffic justifies the license and you want API-driven config instead of reload churn. A service mesh once you cross 50-ish microservices and MTLS everywhere becomes wiring you can't handwrite. Cert-manager to automate everything lesson 8 and 11 setup. Quicks and HTTP3 if you're at the CDN edge. And the most underrated of all, read other people's NGINX.conf. Cloudflare, Wikimedia, Mastodon. 5 real configs a month and your taste sharpens in ways no book delivers. So here we are. 13 lessons, 6 phases, from worker processes tuning all the way to K8s Ingress, from JWT auth in Lua to OWASP CRS at the edge, from your first baseline benchmark to the discipline of measuring honestly. You've earned the title NGINX Advanced Practitioner. There's only one thing left on the command line now: ship. Go run something real in production this week. Congratulations, and thank you for walking the full path.